Example 12, a jet of water flows from a 25 millimeter diameter nozzle at a rate of 30 meters per second. It strikes horizontally a vertical column 150 mm by 150 mm at distance of 2.8 meters from the base of the column. Determine the maximum bending stress that develops. Determine the maximum shearing stress and the deflection of the column at the point where the jet strikes in mm if the modulus of elasticity of the column is 800 gigapascals. So this is the figure. Let's solve for the force, dynamic force F. Then bending stress, because this is rectangular or square, so 6m over bd square, where b equals d equals 150 mm. So F equals q rho times velocity, because the body where the jet strikes the body is at rest, considered as a flat plate. So Q is area pi 0.0125 square times velocity 30, density 1000, velocity 30 again. In newtons, F is 441.8 newtons. So moment is 441.8 times 2.8, so it is 1237 Newton meter. Substitute into bending stress formula, 6m over bd square. So 6 times 1237 times 1000 to convert that to Newton mm, divided by 150 by 150 mm square, so 150 mm cube. So the unit is Newton per mm square, which is megapascals. So the maximum bending stress that develops is 2.199 megapascals. The maximum shearing stress from shear stress VQ over IB, it reduces to 3V over 2A for rectangular sections. So maximum shear is, Q is not the discharge. Remember from mechanics of materials, maximum shear stress is this 441.8 newtons. Area is 150 mm by 150 mm. So 3 times 441.8 newtons over 2 times 150 mm square times 1000, because this is megapascals. We want to convert it to kilopascals. Shear stress is only in kilopascals. So it is equal to 29.45 kilopascals. Then finally, for the maximum deflection for concentrated load at the end of a like cantilever beam like this, PL cube over 3EI. That's the formula for deflection. Recall from mechanics of materials or in theory, structural theory. So where P is F 441.8 times 2800 mm quantity cube divided by 3, 8000 megapascals. Megapascals, 8 gigapascals is 8000 megapascals or 8000 Newton per mm square. So Newton out. This is moment of inertia, which is mm to the fourth. So Newton per mm square, the unit in the denominator will be mm square. So mm cube over mm square is mm. The deflection will be in mm. So substituting, deflection equals 9.579 mm.